Hello everyone. I hope you are enjoying sessions this morning and will have highly enriching learning experience throughout the day. Let me quickly introduce myself. My name is Dipali Kulshreshta. I have got 16 years of versatile experience in designing, developing and implementing software applications and microservices. I'm also a cloud and AWS trainer and I do conduct various practitioner and architect level workshops. Presently, I am working with Royal Bank of Scotland, which is also known as NetWest. Before we dive into the slides, few important announcements to make that during the session, if you get any question, please feel free to write them into the Q&A section and I will be happy to answer those at the end of the session. Secondly, please do participate in the poll after the session because your valuable feedback is very important for me in order to improve my future sessions. And more importantly, try to be active listener throughout the session because there is a quiz contest lined up just after this session. And needless to say, there will be surprise goodies and gifts for the winners. All right, so let's talk about today's topic then. So today we want to talk about Containerize microservices with AWS. So microservices and containers, these are the buzzwords in IT industry and are an increasingly important way for developers to deploy and package their applications. So in next 40 minutes, we will understand the key concepts to use containers as a fundamental unit of compute to deploy any workloads on AWS. All right. And we plan to cover containers overview, Docker concepts, Amazon ECS and ECR, which are the actual services in AWS to orchestrate containers, and finally a demo to containerize microservices. But it worked on my machine. This is one of the big problems in a software developer's life, and I'm sure you must have encountered it in some shape or form. So why it happens? That why a particular change works on developer's machine, but it fails on any other machine or onto the different environments. There can be different reasons to it, but some common reasons are that there can be different setup on different machines. There can be different versions of software installed on different environments. There can be missing dependencies, or you might have different configurations altogether. And possibly you might have hard-coded the directory path or code in the code itself. So to address these problems, a company named Docker came up with an idea to package all these things together and put it into a box known as container. So you can ship your application code along with its runtime, libraries, dependencies, configuration together as a single unit and can ship to any environment and can run it on any operating system, whether on-prem or onto the cloud. And due to this offering, Docker became the world's leading software container platform. It automates the repetitive task of configuring and preparing the development environments. So developers can focus on what really matters to them. And what is that? Building great softwares. Now let's talk about that how Docker works. So since Docker provides a standard way to run our code, Docker is an operating system for containers, so we can run multiple containers on a single operating system. So now an obvious question comes to the mind that how it is different from virtual machine in that case. So in virtual machine, the idea is to virtualize the server hardware. So you can install multiple operating systems onto a single hardware. While in case of Docker, you are virtualizing the operating system itself. So you can create and run multiple containers on single operating system. So the key difference is that in case of virtual machine, you are virtualizing the server. So you can have multiple operating system, and you are further virtualizing your operating system to have multiple containers onto a single operating system. All right. Now, let's talk about some of the key benefits of containerization. Since container provides process isolation, so it made it really feasible to break large monolith application into the small independent components and run them as a microservices. And as it standardizes the code deployment, so it makes it really easy to communicate and create workflows for our hybrid applications. And it definitely made it very simple to migrate applications from on-prem to cloud with zero code changes. And here you can also package your ETL jobs into the containers and can start and scale them as needed. And it comes in very handy to train your machine learning models, and you need to scale them on any environment. And you can also use this concept to build platforms for developers without needing them to manage the underlying infrastructure. Now, $1 million question is that why containerization on AWS? A simple answer is because AWS is a #1 place to run your containers. As on date, 80% containers on the cloud runs on AWS. And some of the renowned customers like Samsung, GoDaddy, Expedia, they have chosen AWS as their container orchestration platform because of its security, reliability, and scalability. You know, AWS provides around 210 security and compliance offerings, and this number is significantly more than any other cloud provider. And AWS infrastructure is more reliable as it has its presence all over the world. So you can really create and deploy your containers anywhere in the world, which covers 69 availability zones and 22 regions. And the presence of this AWS infrastructure is more than double from any other cloud provider. And another key benefit is that AWS ECS, this AWS container platform, is deeply integrated with other AWS services. So you can leverage the agility of containers with elasticity and security of the cloud, which AWS offers as per other services. Now let's talk about ECS, Elastic Container Service. So Elastic Container Service is the service in AWS which made it feasible to orchestrate and create Docker containers into the AWS. And there are some of the key benefits of ECS. That first of all, it offers serverless computing. So you have a choice here that either you can create your containers on traditional EC2 instances and choose to manage yourself, or if you want to get rid of infrastructure overheads, then you can choose to go serverless via Fargate. So if you are using Fargate, then you really don't need to manage any servers. And we will see it in a while. And also, ECS is a fully managed service from AWS, hence highly scalable. ECS is very much secure. because it launches containers into your own VPC. So you can have your own security groups and network access control list, and you can allow or deny any specific set of IPs. You can put your own rules in there. And ECS is very much optimized for cost. And you can further reduce this cost by 90% by leveraging the spot instances over on-demand instances. And this feature is available with both the launch type, whether it is EC2 or it is serverless via Fargate. So this is a simple workflow that how a traditional ECS application works. That first of all, you need to put your container image into a repository. And here the repository service name is ECR, Elastic Container Registry. So this is simply a repository to store your container images. And it is similar to any other repositories like Docker Hub. But the key difference between Docker Hub and ECR is that Docker Hub by default is a public repository, while ECR is private to your account, hence more secure. And then you can define your application in ECS and use this application image while defining the application. And then you can choose your application to run either on EC2 or on Fargate. And then you can monitor and maintain your application. Before we really dive into the demo, let's understand few of the key terminologies which are used in ECS. Whenever we start working on ECS, first of all, we need to create ECS cluster. So ECS cluster is nothing but it is a group of EC2 instances which has some ECS agent software installed on it. Okay. And once we have this basic infra ready, once we have the machine ready, now next step for us is to really define our application. So to define application, the terminology here is task definition. So task definition is a blueprint of your application where you exactly tells that how you want to launch your container. Now you have machine, you have application available on that machine. Now next step is to create instruction. So you can actually run the application which you have defined in your task definition. So task is that instruction. So task is basically a lowest deployable unit here in ECS, which instruct that, okay, how to run your application, which is defined here in task definition. And service. Service is nothing but a group of tasks. Because traditionally, you must have seen that whenever we productionize any application, we run multiple instances of that application to have high availability. So similarly, in ECS, you can have multiple instances at given point in time for your application, and you can define those terms and conditions here in service. And service also provides you an endpoint which you can actually expose to your API gateway or to the outside world. So if we talk about like traditional architecture, how we generally create, what is the best practice to productionize your application? That normally you run multiple instances of your application and put them behind a load balancer. And then you expose the load balancer DNS to API gateway, which is accessible to the intended users or to the outside world over the internet. So that is the traditional architecture. And so this is how we can build here, that we can have multiple instances of our application in service, and then we can expose this to a load balancer, and we can run our containers. Now it's time to get in action. So the very first step to containerize microservice, that we need to have microservice, obviously. So we need to create some microservice, and the bare minimum thing to create microservice Means we need to create a Docker file, and then we need to create image out of this Docker file, and then we can use this image in order to create our application. So how to really create Docker file? So here, okay, let me open an active session. All right. So here I have created a Docker file. So if I see the content of this Docker file, so if you notice this 5-6 liner code, so what I'm doing here I'm taking a base image, some Python image I have taken, and then I'm putting my code into this working directory app, and then I'm installing some of the dependencies under this requirement.txt, and then I'm exposing this particular application on port 5000. And finally, this is the index.py where I have written my application. So let's look at this index.py, that exactly what is in here. So index.py has a very simple hello world application. So index.py has some Python code where we are printing this hello world text, and we are using this Flask to create this web page, right? So Flask is basically a dependency here. So if I show you this requirements.txt, this is basically the area where I'm instructing to install Flask. So here there is just one word, Flask. So Docker file is actually the place where you are packaging all the things required for your application. That exactly what is the runtime you want to use, what are the dependencies, what are the different configurations required for your application, and your application code itself. So this is the area where we are packaging. So once we have packaged all the required things here in Docker file, next step is to create image. But let's see exactly, let's follow the instruction in our presentation. So if you see, the second step here is to create repository, ECR. So how to create that repository? For that, we will need to go on to the AWS management console. And here I am on to the ECR dashboard page. So here I can simply hit on create repository and give some name. Let me give WIT repo. So it will create an empty repository for me. Okay, so if you see here, WIT repo is here and there is nothing at the moment. Now, next step for us to create image out of our Docker file and push that image into this newly created repository. So how we can really create and push image? You don't need to worry about those commands. Simply you just hit here, view, push commands. So here it gives you all the instruction that how to create, how to log in, how to create image, how to tag your image, and how to actually push this image into this repository. So these commands are really for you. These commands are readily available for you. So you can simply copy, paste, and execute. So let's do that now. I'm simply copying this first command, which will allow me to log in. And for this, we are using AWS CLI. So once we have logged in, next step is for us to create image using our Docker file. So here it is creating image for whatever I have written into my Docker file. Once we have created the image, we need to really tag our image. So normally the images which are tagged as latest, that are being picked for your application run. So let's create a latest tag on our image. Once we are done with the tagging, we really need to push this image into our repository, which we have just created. So the moment this step is complete, we should see one image available into our WIT repo. So let's quickly check that. Close this instructions and let's refresh this. Great. So here we can see that we have pushed our Dockerfiles image here into our WIT repo. Let's refer the slide again. What is the next step for us? So next step for us is to create ECS cluster. So far we just have created, we have written our application and we have created image which actually bundles all the required things required to run that application. And now I want to run my application onto the container. So very first step I need to do that, I need to really provision machines where I can host my containers. So from where I will provision those machines? From ECS. So let's create ECS cluster. So here I am onto the ECS dashboard. And if I go onto the cluster and hit create cluster, so here you get options that you want to host your container onto the Linux environment or you want to use Windows environment. For this demo, I'm using the Linux platform. So we can create a cluster here. For the simplicity, let's give WIT cluster. So this is the unique name I have given, and I'm using on-demand instances here, but for actual production loads, we should leverage the power of spot instances. And considering this is a very small Hello World application, so let's choose some smaller T2 family instance. Let's go with T2 small. And here I can, I'm happy with just one instance, but yes, practically you might want to create 2 or 3 instances for your for your container orchestration. And then you can also choose some key pair. So if you really want to SSH to your instance. So here I have chosen the existing key pair. And this is the area where we were talking about the security. That here you can, because in AWS, you can actually implement security at each and every layer. So in case of ECS, that yes, it allows us to create containers into specific VPCs wherever we want to. So I'm using this VPC. We can choose any subnets for this. These things I'm keeping default security group. So either we can create a new security group or we can choose any existing one. I'm choosing this security group, Launch Wizard 4, and I will tell you the reason in a while that why I have picked this. Rest everything we can leave default. So I'm simply creating this cluster. So while this is creating the cluster, let's talk about the security group. So if you remember in my application, in my Docker file, we exposed port 5000 that my application should run on the port 5000. So I really need to open this 5000 port if I want to access it. Okay. So, and where we open any ports, security group is the place. So if you see the inbound rules here, I have opened this port 5000 to anywhere. Means if I am using this application on port 5000 from anywhere in the internet, I should be able to access it. All right. So either you can create a new security group and open this port later, or you can do these configuration in advance and use that security group while creating your cluster. Let's see if our cluster is ready. Yeah. Great. Now let's quickly refer to the next step. So once we have created this cluster, means we have created our application, we have created image, and we have pushed this image into the repository. We have also created our machine. So at this stage, since I have chosen the EC2, so it must have created EC2 instance into my account. Let's quickly check that. So here, if I go to my instances, try to refresh this. So if you see this particular instance, ECS instance, this is something we have not created manually. It got created via ECS cluster creation. And if I just scroll right, and yeah. So if you see the timestamp here, that this is the instance which has just created when we created our ECS cluster. Okay. So next step for us to define our application, and how we can define our application via task definition. So go back to ECS, see the task definitions here, and then this is the place where you need to create task definition, means you need to create blueprint for your application. So let's hit on new task definition, and launch type, I'm choosing EC2, but yes, if we want to go serverless, we can definitely leverage this Fargate. Okay, next step, give some name. So WIT task definition I'm giving here. You can create role and tag that role here, or I'm just going with the default. I'm not defining any role here. So mostly settings I'm going with default for this particular demo, but yes, when you are doing real configuration for production application, then yes, these are the places where you can make your application more precise and secure. Okay. So the key thing here that now in order to define my application, I really need to link it with the image I have created in ECR. So this is the place where you can link it with your image. So what is the container? We need to give some container name where to define this application. So simply I'm giving WIT container so I can distinguish. This is the place where I need to provide the URL of my image. So how we can get that? If I go to ECR and simply copy this unique identifier for my image and just paste it here. And yeah, one important thing to understand here, in AWS, it is not mandatory that you need to really use ECR as your image repository. You can very well go ahead with any other repository like Docker Hub. And this is the place where you need to provide complete path for your image, wherever it is available, either in ECR or outside ECR. Okay. Now, when you are defining your container, you need to define some memory limit for your container. Considering this is like a small hello world application, so I can define a soft limit here, maybe like 1 MB type, so 1024. Let me define that. And this is the very important point to understand, port mapping. That what is your application port, and at what port of your container you want to run this application. So if you remember, in my application is running on port 5000. For simplicity, we can choose to run this application on port 5000 of our container. Okay, so this mapping is must. So whenever you define any application, please be careful that you are not messing up with this port mapping. Rest everything we can leave default. Yeah, simply add this container to your task definition and hit on create. So it says task definition created successfully. Now let's refer the slides again to understand what is the next step. So what all we did so far, we created our application, we created image of our application, we pushed that image into the ECR, and then we simply created infrastructure, machine, with the ECS cluster, where we can host our container. And once we have the machine ready, we defined our application where we really linked this image into the task definition. Now, next step for us to create instruction. So we can actually run the application we have defined into this task definition. So for that, we need to create service. So either you can run task directly or you can create a service. So best practice is to create a service. So if we go to clusters and open our cluster, the very first tab you will see here is service. Just simply hit create. So while creating service, it will ask you that what launch type you want. So we will go with EC2 for this demo. And then by default, it has picked the task definition name. So we created WIT task definition. So we need to pick that. And what is the cluster? So it has picked that WIT task definition is linked with this WIT cluster. I need to provide some service name. So the naming convention we are following. So let's do this WIT service. Then this is the place where I was defining that you can simply define that how many tasks of your application you want to run at any given point in time. So typically these are normally at least 3 or 2 tasks you define. But for this demo, we can go with just 1 task. You can also define that what kind of deployments, because if you need to send revisions, if you need to really deploy different version of your application, then you can choose here that you want to go with rolling updates or you want a blue-green sort of deployment. And then simply go on to the next step. This is the place where you can link, because if we would have created multiple tasks, then we need to create some load balancer and we want to run those multiple tasks behind this load balancer. So this is the place where you can link it with any load balancer. As of now, I'm not choosing any load balancer as we have not created any, because we are dealing with single tasks. So we don't really need to load balance. And also you can define your scaling policies here, that like traditional scaling, which we define that, okay, if my CPU load is going beyond 70%, please add 2 more tasks for my application. So that kind of scaling policies in order to increase or decrease the infrastructure, you can define here. Simply go on to the next tab, review and create. So here it says service created. Now let's view this service. So it is like this service should be available here. Let's refresh. It might take a moment. Yeah. So here we can see this status is running. Considering this is a very small application, so it didn't took any time and straight away we could see this running status here. But in real applications, you can see that for initial 1 or 2 minutes, you might see the status here as pending, but the desired status would be running. So as of now, it is saying that our task is running. What does that mean? Means our application should be in running state and I should be really able to access that application. So how to access that application? So if I check the details here, if I try to expand this, so you can see the details that this is the application which is running on port 5000 at the application side, and the container port is also 5000, which we defined as part of port mappings. And this is the link to run your application. So if we simply open this tab, we should be able to see our running application. Here you go. So here we can see that our application is running because this is something which we defined in our application index.py. So if I see here, if I simply scroll up, yeah, if you see, this was a similar text I had, hello world and then exclamation. So this is what we are seeing here. All right. So this is how you can actually create your application, put them into a container and run your container by leveraging the ECS. This is the end-to-end flow, which I really wanted to demo as part of this session. And I understand like things look very simple once you're comfortable with it. But when you really try it for the first time, you might struggle at various stages. So what I have done, like I have created detailed tutorial steps here and put it onto the Medium. So if you are not comfortable with ECS and want to explore this, you can go to this blog. Let me show you. Here it is. So if you go to this Medium blog and look for learning Dipali, learning.dipali tag, you will see that here I've created this tutorial which has detailed steps, that how to create a microservice, how to create Docker file, and all the detailed stuff which we actually did as part of this demonstration. And from here, you can simply copy paste this code if you really want to replicate the same application. So it's up to you. So you can really explore these steps later and try to create your first containerized application and host it on ECS. I hope this session was useful for you guys and you will leverage these learnings in future. I hope it was a well invested time for you guys. Now let me have a look at the questions if we have any. Could you please provide more details on Fargate? Yeah, so as we choose our launch type as EC2, means I had full control that exactly what all EC2 instances my application has created. I can SSH to that EC2 instances. I can see the various details around that application, that what is the memory usage, what is the CPU usage. So those kind of controls I can put in if I am using the EC2. But if I'm using the Fargate launch type, I won't be seeing any EC2 instance here into my console where I can really log in and see. Everything will be managed for you in the background by AWS. So simply if you choose Fargate, you will not be able to see any EC2 instances here. You will not be able to log in and it will be just seamless for you. You just choose Fargate and everything will be done for you automatically in the background. So this is what the Fargate is. And can we choose any particular location data center to create a cluster? Yes, as we have option to choose VPC and the subnets. So there, if you notice, I choose different subnets in my VPC. So suppose my VPC is there into Northern Virginia region, means I have like 5-6 subnets available. So I can choose exactly where I want to create my container. Great. So we don't have any more question at this stage, but if you get any question and if you want any clarification, you can reach out to me today, definitely via this platform. At any time you can reach out to me or you can reach out to me on the LinkedIn profile. So I have really published my LinkedIn QR in the beginning. I'm showing it again. So you can scan and connect me over the LinkedIn. Okay. Or simply just find Dipali Kulshreshta, so you will be able to spot me there. So please feel free to ask any questions now or later, and happy learning, guys.